Bismillahirrahmanirrahim. I am Muhammad Ehsan Chatta, Assistant Professor, Government Degree College, Chawadni. Dear student of the B.Sc Physical Chemistry, let us learn about the gases chapter article mean free path molecular collisions. First of all, we learn about mean free path. Mean free path or average distance between the collision for a gas molecule may be estimated from the kinetic theory. Survey approach is a good visualization. If the molecule have the diameter d, small d, then the effective cross section for the collision can be modeled by as in diagram. Two molecules of the gas, they are moving in opposite direction. When they are collide among themselves, the effective collision area will be equal to A is equal to pi d square. A is equal to pi d square. Using the circle of the diameter 2d to represent the molecule effective collision area while treating the target molecule as the point masses in time t small t, the circle would sweep out the volume shown, and the number of collision can be estimated from the number of gas molecules that were in that volumes. So when two molecules collide among themselves, the effective collision will be represented with capital A, and that's equal to pi d square, while the central location of the target molecule, its volume of this cross cylinder, if the molecule size here one molecule move and do another molecule move in opposite direction, molecule per unit volume represented NV, and its cross sectional area, that is equal to mu t, then the volume would be volume will be equal to pi d square into average velocity multiplied by time per unit time. The mean free path could then be taken as the length of the path divided by number of collision. Mean free path is defined as the length of the path divided by its number of collisions. Mean free path that is estimated that can be divided by number of collisions. So the equation velocity distance traveled, yani Vt distance traveled over pi d square Vt, it is the volume of interaction, while Nv number of molecule per unit volumes. Distance traveled divided by volume of interaction multiply by number of molecules per unit volume. By again simplifying this equation, mean distance per collision will be equal to distance traveled will be present in numerator as well in denominator. It is cancel out. The remaining equation will be 1 over pi d2 nv. Pi d2 nv, it is known as mean distance per collision. The problem with this expression is that average molecular velocity is used, but the target molecule are also moving. The frequency of the collision depends upon average relative velocity of a randomly moving molecule. Mean free path calculations. The mean free path equation depends upon the temperature, pressure as well as diameter, molecular diameter. For pressure, P naught unit in millimeter mercury and are expressed in kilopascal. At temperature capital T, that will be taken in Kelvin, centigrade and Fahrenheit scale. The diameter multiply 10 power minus 10 meter to convert it into angstrom. Molecular diameter into angstrom multiplied by angstrom should be the mean free path will be equal to small lambda. Mean free path represent lambda will be equal to RT divided by 2 pi d square under root yani square root multiply by Avogadro numbers Na and into pressure, that will be equal to multiply by 10 power 10 meter, and it is converted into angstrom, which is the time, the molecular diameter and times average molecular separations multiplied by 10 power 10 meter. The value of pressure, temperature, molecular diameter may be changed above to recalculate the mean free path. Nominal molecular distance is 0.2 nanometer. 3 multiplied by 10 power minus 10 meter, which gives us a reasonable approximation. The pressure required for a given mean free path can be calculated by changing the value of mean free path small lambda as in above. The calculation is not designed to allow any other changes. Their values will be replaced unchanged by the calculation from the mean free path and the average velocity. The mean time between the collision and frequency can be calculated also. Average relative velocity. In order to calculate mean free path for a molecule of the gas, it is necessary to assess the average relative velocity of the molecule involved rather than just average velocity. And we use the average relative velocity in place of average velocity just of the given molecule. The relative velocity of any two molecules can be expressed in terms of their vector velocity. Then the velocity of the molecule, one molecule is known as V, and another molecule as in given by arrow V2. A random molecular collision, when they collide among themselves, these two molecules with the velocity in opposite direction V1 and V2, the second velocity become inverted with negative sign v1 and minus v2, the relative average velocity would be equal to velocity number 1 minus velocity number 2. The magnitude of relative velocity can be expressed as the square root of the scalar product of the velocity with itself. Relative velocity will be equal to relative velocity 1 and similarly relative velocity 2 and its square root, and it is scalar quantity. The expression can be expanded and taking average on both sides we get the relative average velocity will be equal to square root of the relative velocity average velocity 1 molecule plus relative velocity of the second molecule. Since the same average velocity would be associated with each molecule, this becomes the average velocity will be equal to 2 average velocity square root. This is all about the collision, mean free path and relative average velocity. Thank you student. Allah Hafiz. Take care.